Okay. I agree. Are there other things that
Imaginary numbers.
yes. Yes. For those
Oh, okay. You just said one also vacuum.
like when you connect to
Oh, you didn't tell me out at any of that.
Okay. So when something that pulls or pushes on an object. Now, I'm going to be really forces. Like those are good. So a pull and a push is important. Change this something that. Is that okay? Can I alter what you're saying? I'm gonna use. I'm gonna say a pull or on an object, and on an object is caused by an object. Yeah, on an object by another object. This is super like big stars. Like that's super.
Um, it can be either physical or non-physical. Like, there can be caused by like um, either an object physically touching it, or the object has like a gravitational pull.
So you said what, physical or non-physical? So these are in like contact forces. So that's like another contact. But there's some contact dropping close. But it's dropping down. So there's like so
From or
which is a non-physical force or a non-contact. That's what you might see in the book. Okay. Like gravity is really an interaction. And all of them are true. And drop together. Yeah. So and Really. Did you guys all hear that? She didn't say it very probably Jupiter. I don't buy it. All right. Oh, I know. You guys have met this guy, yes? You've heard of this guy, though? Yeah, you have it. Sir Albert? Yes. Yes. He really loves non-contact forces and non-physical. Call them. I love this. It makes me happy. It's gonna make you happy too. Spooky action at a distance. Like he actually said that. Like that is literally spooky because we digress. Okay. Back gravity. And we got this gravity thing, and that's one of those any other magnetism is another one. I can write one. Too spooky for you? No. Any other spooky? Electricity is spooky. Is that what you're gonna say? Here's a secret. This is the same thing. There are two spooky forces. Any superheroes? I don't know. You're not really the big deal. No. There's my super. Who was that? You? Okay. So this is the one that we know a lot about, right? Gravity. So tell me, you studied gravity then too, right? You draw stuff. Yes. I'm gonna break.
are we sure gravity is cold and not? I don't know. I was thinking about this. Like,
Maybe we're being pushed by
like,
Jupiter more than
are we sure that the Earth is like pulling us, or is it pushing us?
Maybe something else that's like a big.
I'm, I don't know if I
How are you gonna? The frog, depending on how close you were to the frog. Oh, the frog would start going. The frog and Fletcher would start moving towards each other, but the frog would be moving faster because Fletcher has a bigger gravitational pull. Has a larger mass.
Are you gonna leave me out there? Or do I get to come back?
that's like
But she left, so she left. How am I?
Yeah.
I don't know, like, can you keep bringing me food? I'll stay out there.
so. Wait. And then you stick your tongue out at the concept of imaginary numbers. Come on.
Never mind. I think I am.
And these whole keywords here are an object, by an object. How many objects are we talking about? Two objects. Down. Objects. Two objects of importance. How do these things cause motion?
So you said we don't know much about gravity. So you're teaching us about stuff that we really don't understand.
I'm do
Well, that sounds less ironic.
like okay. Okay. Are we okay so far? Okay. Now, before I move on, I do want to ask, were there any other definitions? Were there any definitions? Yeah.
The change in velocity for the object.
And after I write it down, then I'm going to disagree with you, but I want to write it down first. Causes a change in velocity for an object. And by change in velocity, we could also say an acceleration. Is that okay with everybody? Okay. Sometimes I'm going to make notation at the notation that I'm writing up here. A force. So it's just like another definition. It's a pull and push. Does that make sense? Thanks for asking. Yeah, go. The little arrow, like this can be extrapolated. Like yeah. Change of velocity means acceleration. Yeah. Ask this question, so I just write it. Okay. So, frog, yes. I let him go. What's his velocity right now? I let him go, and what's going to happen to his velocity? It changes at least, right? Change of velocity, so that's good. So he accelerated. So, did a force cause a change of velocity? Yes. Yes. Okay, so I agree with you. Now, I want you to look at the frog right here. Can you guys see it? Okay. So the frog is sitting there. Is his velocity changing right now? No. No. Are there forces acting on him right now? Yes. Okay. You see where I'm going? Okay. So, we said that a force causes a change in velocity. But there are forces, and there's no change in velocity. See that there? Something's not quite right. There's a word or a phrase that okay. Okay. Then that force. Okay, again, I also. Yes. Okay. 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 So here's the thing. Okay. So there's something going on, and you call it something. Net force. A net force. Yeah, that means like overall total. Total force will cause acceleration. That's an force. Okay. Okay. Cool. So I'm gonna ask you. So I'm gonna put a little because it's a net force. Yes. Okay. Now hold on to that. Okay. We're gonna do some examples. These are pretty simple examples. Example number one. is just going to be the frog on the table. Okay? I want to look at and you're like, well, what's the question? We're going to use the frog on the table to learn more things. So you're telling me that the frog is not accelerating. And but there are forces acting on it. So I'm going to write down what those forces are. So I'm going to go ahead and draw my frog. You draw a frog. And my frog doesn't have to be easy. There's my frog. You draw your frog. We want to draw all of the forces that are acting on the frog. By doing that, we're making what we call a free body diagram. All of the consequences. Okay. So I'm going to draw the force of Jupiter, or the force of Flex, or the force of Mars, or the force of me, or the ones that are probably going to impact. I mean, so, a free body diagram, just going to kind of define this for us here too, is a picture or a diagram, I guess, of an object. How many objects? One. Of one object. And all of the forces acting on that object. And again, you could say all of the consequences. That's really small. Really small, please let me know. What forces are acting on the frog? That's when I want to share my yeah. Right. Now I'm gonna be really picky though, because forces are an interaction between how many objects? Two. So if I'm going to write down this gravity thing you speak of, really, it's the force of what on the frog? The earth on the frog. You see what I'm saying? Like, I'm going to get picky because I really want you to define that force on the frog go. Down towards the center. Actually, and I'm going to write the force of the earth on the frog. And I'm going to put F sub G because you know that it's a gravitational force. It's a spooky force. Okay? I'm going to write that there just so I don't forget.
What's specific above the
It is. It is. Yeah. Oh, it's, yeah. It's fine. Yeah. What else is acting on the frog? Put it on. Yeah. Because it's confidence. The table is acting on the frog. Absolutely. Let's go ahead and draw it. Which one is on the frog? Pushing up. Really? You don't need to say that unless you really believe it, okay? Okay. Which way is it going, Gemma? Now, when I draw these vectors, the force of the table on the frog, how do the sizes of these two arrows, how should they be about the same? Now, I'm not going to get my ruler out and measure. But you want it to be about the same because if you add these together, let's do it. I'm going to write that down. Add these two things together. The force of the table on the frog plus the force of the earth on the frog. What should they add up to? They add up to zero because it's not accelerating, right? That makes sense. What's up, Andy?
Don't we usually go that arrows?
That's a really, really good question. And you don't have an arrow going from the middle of it, but you do want all the arrows to come from the outside. Are you okay with it? Okay. So far, so good? Okay, so we're kind of done with that example. We'll come back to it in a minute. All right. Ooh. So we're going to just stop for one. The floor is right. I would move so that I would say when you stop the roller. All right. I could. All right. So the throne on the table is really one example, right? There's not a whole lot of exciting going on. Okay? You can see them around. There you go. All right. We're going to look at four different situations with the bowling ball. Are you ready? Watch this. We'll do it a couple. The first one is here. This is A, B, C, D. Okay. Watch it again. You ready? Then we're going to go draw pictures in a minute. So I want you to just kind of get them in your brain so that you know what's going on. So here we go. A, B, C, got it? All right. So now I want you to turn back to your seat. Stop the bowling ball. Woo! All right. Here we go. Example is the bowling ball. And we're going to draw all four faces in one kind of B, C, D. Now, remind me what's going on in case A. What was going on in case A?
You were holding on to the ball. Oh, okay.
So yeah, in that one, I'm going to say. Do you want to do case B also? Would that be okay?
I don't know.
Okay.
You were pushing the ball.
C. And then okay. What I'm Okay. That's the first one. Just
We didn't do anything.
Okay, one more minute.
Right. 6 Based on all right, let's take a look. I want you to hold them up there. Good. Let's see here. Okay, I want you to take a look at these pictures. They all have arrows that are coming from the objects. Do you agree? So that's good. The next thing that I'm looking for is that all of the forces are labeled as F of one object. It has to be something tangible. Has to be something tangible on ball. Okay? So we've got floor on ball, some sort of, okay, Thunder, I'm starting with you because you're just on the end there. What is that second one, the one on the horizontal one? Okay, where do I go to buy a push? Can you hold a push in your hand? No, so I need an object. Was there a push that was going in this direction? Sure. Who or what caused it? I did, right? So that would be like the force of carbling on the ball. Or if you wanted to like disembody my hand, you could say the force of the hand. And that's okay too. Either one is fine because those are things that are physical objects. Does that make sense? Okay, so I'm going to say the force of the hand on the ball or the force of carbling on the ball. Or the force of, as Mara says, the force of the teacher on the ball, right? Certainly. Okay, now, so we've got the earth going down. Is the floor still pushing up? It is still pushing up. There's no reason, the floor's still there. The other thing that you don't have to fight about it. It's okay. Nobody's going to remember in 35 seconds anyway, except, now they are because I'm pointing it out, right? Because I want to look at that picture, and I want to look at that picture. I'm totally going to You got two forces, right? So this was like A. Do you all agree? Those two forces, they add up to what? Zero. Does that make sense? Yeah. So we can tell where the net force actually is. There is none, right? Because they add to zero. Now, if we look here, two forces opposite, like in where would the net force go? Right? It would like go that way. Does that make sense? I just want you to think about it. That's deep. Okay. Now, our teacher on both and like that one, that's understand all space. These are all the same. This one here, if you have something else acting there, what do you say? Friction. Okay. Now there's different pieces. This is I love it. This is like so the force of yeah, like in third grade, your teacher like, oh yeah. Force of friction is just two things rubbing against each other. Now, was there friction in this case? Yes. Yes. But from here on out for this conversation, I want you to assume that I came in early this morning and I polished the floor, and then I got my bowling ball washing kit out, okay, and I washed my so that it's nearly friction. Sure. So I'm imagining, right? So I'm not saying you're wrong, but I'm saying now for the remainder of this event that we're doing for right now, does that make sense? We're going to assume that there is no friction. Everybody catch that? Yeah. No friction. All right. And let's see, what else we have? Okay, so there, tell me what that one says. How many of you have heard of the word inertia? Okay. Inertia is a nice word, but number one, I can't go out and buy inertia, right? Okay? I can't hold inertia in my hand. Inertia is a word that I just want to kind of like not worry about. Okay? Do things have inertia? Sure. How do you get inertia? What do you increase in order to increase the inertia? What's inertia? That's what I'm trying to figure out, right? Thank you. That's what I'm trying to figure out. What is inertia? Does anybody know? Because there are some people that said, yes, I've heard of inertia. If I want to increase my inertia, what do I do? It does. So inertia is something's willingness to move or be stopped, to accelerate, if you will. Okay? So if I have a golf ball and I have a bowling ball, which one's going to be easier to get to move? The golf ball, right? The reason for that is because it has less inertia, but we know it's because it has less mass. Does that make sense? It's kind of a fancy word for mass. For what we're talking about is a fancy word for mass. So if you need to write that down in your notes, you can do that. Inertia, fancy word for mass. And so I'm going to say, is there an inertia on the ball that's going that way? Is that something you can buy? Is that actually a force? It's not. It's not. So it's not something we're actually going to put on everybody out there. But it's good that we put it on there so we have this conversation, right? And everybody yours looks like those, right? Okay. That was a good little conversation. I want you to go back to your seats. If you need to fix your picture for letter B on your notes, go ahead and do that right now. And then erase your whiteboards. Okay. With that person right now, I want you to do And I'm going to ask you what that says first thing. And so
It says the force of they don't know.
Okay, put that one down first because we all agree. Down. Force of the earth to fall for sure. Ball. Do we pushing on? Yes. To the floor on the ball. Okay, so that's two. Now, force of we don't know what it is. The only other choices, let's go back and look at our list. The only other choices are electricity. Are there any other forces acting on the ball? No. There are no other forces. This is weird. This is weird, and this answers the question. Moving, but tell me about motion. Oh, that's a huge deal. Say it loud. Not accelerate. This is a big deal. This is like we need to write this really big in our notes. Okay, here's the thing. Let's notice.
You can't tell from a free body diagram whether or not this thing is what was it doing here? Or rolling at a constant rate, pace, velocity, things like that, right? Okay? They look exactly the same. We can't distinguish between a velocity of 0 and any other constant velocity. Okay? The only thing we know is that it's not what? We know that, yes. We only know that it is not accelerating. We only know that the net force is equal to what? 0. Is that okay? Are we doing okay with this? Okay? So, Riley, this kind of answers the question you were asking. Okay. So I just want to make sure that we've kind of gotten that. So we know that it's not accelerating because the net force is 0. That's a big deal. That's a huge deal. If you can get that into your brain and remember that, you are almost good to go for this entire chapter. Now, there's always an almost, right? This is the big concept you need to know. Okay? Big deal. Good thing it's a Friday. We know that. Now, before we go, because we've got 2 more minutes, I want you to pass that whiteboard one more person to the left. So everybody unless you have a key, and I want you to everybody to go. So what happened when you always forget? Stopping it, right? It was during the stopping time. The ball was being stopped in the story. The ball is being stopped in this story. Person, what does that say? Person on what? We need two objects, right? Ball. Bring it on ball. Me on ball. Okay. Are we okay with it?